Oh, hi. I didn't see you there. My name's Adam McQueen. Have you ever wondered what happens to an object in motion when it comes to a complete stop? Well, today, me and my associate Spencer Orsi will be doing a thorough investigation to find out what happens to a bike when you slam on the brakes. You'll be surprised what you can discover if you put your mind to something. Let's go see what we can do. As you can see, it took some force as well as some time to stop that object in motion until it came to a complete stop. Why is that? I'm going to turn this over to Spencer so he can go into greater depth of the situation.
From our scenario, we were able to identify three variables: the initial velocity, change in time, and the displacement. By using these values, we can identify the acceleration by using one of the Big Five equations.
Hey guys, it's Adam. I'm going to be explaining Spencer's work here. So first we decided which Big Five equation to use, and then we subbed in all our knowns. From there in our first line, we decided to multiply our initial velocity by our time value. When we did that, we got 6.72 meters per second. In the same line, we squared our time value to get 1.44. In the next line, we have that to get 0.72. In the next line, we subtracted 6.72 from 6.9 to get 0.18, divided both sides by 0.72, and got our acceleration to be 0.25 meters per second squared. Now that we found the acceleration, let's have some fun and talk about energy.
Before we go any further, what is energy? Energy can exist in a variety of forms, such as electrical, mechanical, chemical, thermal, or nuclear, and can be transformed from one form to another. It is measured by the amount of work done, usually in joules or watts. On the left side, you can see our energy flow diagram, and the bike being in the system and the road being outside the system. The bike is giving the road energy, which means negative work will be done.
On the right side, we have our energy bar chart and our two events. Our first one being slamming on the brakes, and the second one being coming to a complete stop. On the left side of our chart, we have 3 bars of kinetic energy and none of thermal, as we are still moving at a fast rate while slowing down. Then we add our negative work, which is the friction working against the bike. On the right side, we have just 2 bars of thermal energy, as the friction has created some heat with the tire. Alright guys, that's all the time I have for today. I'm your host Adam McQueen with my trusty assistant Spencer Orsi. Tune in next episode for your daily dose of 3-minute science.